Okay, so today I want to talk about this display, which is a reflective LCD display. It doesn't have any backlight, so if I turn off the lights, you will not see anything. But on the other hand, it's nicely readable on the direct sunlight and it consumes almost no energy. In many ways, this is similar to the e-ink display, I mean as for the power consumption, which is again extremely low, except if you disconnect it, the image will not stay displayed, so you have to provide a tiny bit of power all the time. However, unlike the e-ink display, it can update much faster and you don't get that annoying flickering that you get with e-ink displays. So this might be a perfect display if you want to do some battery-powered project, and today I will show you how to use it with the Arduino UNO board. By the way, this display is very similar to the Sharp memory display, maybe it's the same, I'm not quite sure, and Adafruit sells those displays as modules. You can get the smaller one or the bigger one, and I do plan to use those displays for some future projects. By the way, this big display is the very same display used for the Panic Playdate game console, which might be a great tip for a Christmas present if you don't have anything yet. Anyway, back to our project, and let's talk about the sponsor of today's video. And the sponsor is PCBWay, because if you are making electronic projects, sooner or later you might need PCBs or PCB assembly or SMD stencils, or even services like CNC machining or 3D printing, and in all those cases, PCBWay has you covered. They offer all of those services for a reasonable price. By the way, if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our project. So again, I will be using this reflective LCD display. And if I turn it around, it says that it has the resolution of 122 by 250 pixels, actually the other way around because I will be using it in the landscape mode, so 250 by 122 pixels, and it uses the chip named ST7302 with the 4-wire SPI connection. And if you search for the chip name, the ST7302, you will actually find quite a lot of pages. For example, this GitHub page with the Arduino library for the display, or this page where someone was requesting support for this display on the U8G2 library, and if I scroll down, you can see that it was eventually added, so this is the U8G2 library running on this display. You can also see this image on the gallery page of the U8G2 library, and again there are a lot of different displays, and this is the one that we are looking for. There are some notes about not supporting the U8x8 or the hardware flip, which we don't need. But what we do need is this initialization line for the display itself. So let's just keep this open, and I will start with my previous project, which is this one where I have used the VFD display to show two gauges. So I will go to the source files on the GitHub page, and in here I will locate the INO file, which should be in here, and then I will just copy this into the clipboard and paste that code into the Arduino IDE. Of course, I need to go up and change the initialization for the used display, which is this one, so we are not using the VFD display anymore. We want to again use that display, so just copy the initialization line and also copy this into the Arduino IDE and get rid of the older one. And I will actually delete the whole VFD section so there is no confusion. And let's keep the rest of the sketch as is for now. I will just connect the Arduino UNO to my PC and select it from there. And then I will upload this project to the Arduino UNO by clicking the upload button. Once this is successfully uploaded to the Arduino UNO, we need to of course connect the display to the UNO. And there are 7 pins on the display itself. The ground should go to ground and the VCC should go to 5 volts. And then if I look at the initialization line, I can see that the CS, the chip select, should be connected to pin number 10. Then the DC, which is the data command, should be connected to pin number 9, and the reset should be connected to pin number 8. We still have 2 pins which are not connected yet, and those are SCL and SDA. The SCL is the serial clock, and the SDA is the serial data. And since we are using the hardware SPI connection, we don't need to define those in the code, because those pins are hardwired and we cannot change them, at least not on the Arduino UNO. So instead we need to open the Arduino UNO pinout, and we will see that for the SPI connection the clock is connected to pin number 13, and then we have 2 SPI data pins, one for sending the data from the Arduino to the display and the other one from sending the data from the display to the Arduino, but this time the display is not sending anything back, so we only need to connect one pin, and that's the pin number 11. So with everything connected, we can hit the reset button on the Arduino board and we can see that the image updates on the display, which is great. Obviously, it's not perfectly fitting on the display because the resolution of the VFD display was slightly different, so that's kind of expected. But what's not expected is not seeing any animation, because those gauges should be animating and they are not. Actually, from time to time, there is a slight blink on the corner of the display, not quite sure if you can see it. But if you've seen my previous video about the VFD display, this might be a clue why it's not animating. And that's because I was making some optimizations and only redrawing a portion of the display, and the display is being split into multiple pages, and I believe I was only updating one page. But on this particular display, I think it's rotated by 90 degrees, so the page is actually going from bottom to top instead. That's also the reason why we see a blinking from time to time in the corner, because this is the actual size of one page. We can easily test our assumptions in the code. In here we are drawing the full screen background image into setup function, so let's actually not do that, let's comment it out. And then inside the main loop we keep the track of the current page, and it looks like that we are only updating one page, so let's maybe increase it to maybe like 4 pages. And let's try to upload it one more time to see what happens. And as expected, we do see the animation now, and it's only happening on the left side of the display. So our assumption was correct, the pages are going from the left side to the right side instead of from the top to bottom. So for now, let's not worry about any optimizations and let's just update the entire display all the time. So inside the setup function, I will again draw the full screen background image, and then inside the main loop, I will just not worry about the current page, so just comment out this line, which means that this loop will update all the pages. So let's upload it one more time. And now we can see that only portion of those gauges are displayed and it's actually being animated, but it's of course very slow. And I say of course because I'm usually using the Arduino UNO together with the OLED displays that have the resolution of 128 by 64 pixels, whereas this particular display has the resolution of 250 by 122 pixels. So that's almost 4 times as many pixels that we need to update. As a result, you can see that it's updating roughly 1 or maybe 2 times per second. That said, I think that for some gauges, this might still be acceptable. But what's not acceptable is only taking half of the screen space and actually going outside on the right side. So let me update the graphics to match the display resolution a little bit better. Same as the last time, I'm using Photopea to create the graphics, and Photopea is a free online graphic editor similar to Photoshop. And I've already opened the design for the VFD display, which looks like this. And I want to update it for a new resolution, but this time I actually want to see this design at the same time. So what I will do is I will create a new artboard, so a new kind of canvas, and you can do that by right-clicking this tool and selecting the artboard tool. And first of all, we need to draw the artboard around the current graphics, which will be the resolution of 256 by 50 pixels. And then I will create one more artboard, and that will be the resolution of our display, which is 250. I guess I need to start again because I need more space in here, because the resolution is 250 by 122 pixels, and maybe move it around a little bit just like so. So now we have the old design and the new design. So the old artboard, that's the VFD, and the second artboard, that's the reflective LCD display. I will create a new layer in there and fill it with black color, so edit fill with the black color. And then I will create those gauges simply by again creating a new layer and creating a selection, I don't know, maybe like this, so maybe 200 by, let's say, 24 pixels, and then fill it, but this time fill it with the white color instead, so that will be the base for the one of the gauges. And then I will use a very similar steps as for this design, so if you want to know more, please watch the previous video because there I describe every single step with more details. But just to briefly go over my process, I will create rounded corners by drawing some black pixels over the edges of the gauge. Something like this. And then I will create a new divider and duplicate it multiple times. And then I will borrow some labels from the previous design, so select the label and then duplicate it and move it into our new artboard. And maybe I want to make it slightly bigger. Maybe let's go with 18 points. And I will switch the anti-aliasing to be strong instead, so there are more visible pixels. And then of course I need to apply the threshold effect because I only need black and white pixels. And I can tweak the threshold, maybe show more of those pixels to not have this, jagged look of the edges. So maybe something like this. And then of course I need to duplicate this, and that will be F for the full, and move it on the right side. And then we need one more label in the middle of everything, so 1/2 of the tank for the fuel gauge. And actually make this smaller, so maybe go back to, I don't know, 15 or so pixels, and we will have to tweak this anyway. Then I will create a new layer, and again I will draw the line with the pencil tool going from the letter E to the middle, and let's make it 2 pixels wide, like so, and then duplicate it, move it on the right side. And let's actually tweak this label a little bit, again by drawing some pixels with the pencil tool, maybe get rid of those pixels, and tweak this shape slightly. Okay, I think that this looks fine. For the first gauge, I still need the fuel icon, and since everything is slightly bigger on this display, I want the fuel icon to be bigger as well. So I will duplicate the fuel icon and move it into our new artboard. And I want to resize it to be bigger, and I can do that by going to Edit, Transform, Scale. And I want to scale it to 200%, but if I do so and click the OK button or Confirm button, you will see that everything is kind of blurred because it's trying to get those details back, and we don't want that. We want a pixel kind of look. We don't want to do any filtering. So let me just go back and do it one more time. So Edit, Transform, Scale, and I will again scale it to 200%. But this time I don't want to apply any filtering, which is this drop down menu, and the no filtering means this one, the nearest neighbor filtering. And if I apply this scale this time, you can see that we have now double pixels without those in between grayscale blurry pixels. I still need to tweak those sharp edges, and for that I will again use the pencil tool, set to only 1 pixel, and just draw black or white pixels in those areas. Maybe something like this. Let me quickly create the second gauge in the very similar way. And of course you can tweak it as much as you want, but I like this design, so the only change that I will do is I will try to simulate the gauges in the different states. And for that I will again create a new layer, and then select the selection tool and maybe select part of the gauge, like maybe this one, like the inner part of the gauge, and then I will fill it with the black color, so edit fill with the black color. So this is how the gauge might look like when the gauge is slightly filled. And let's do the same thing for the second gauge and maybe show it in a different state, maybe like so. And again, edit fill with the black color. So this is how the design might look like when those gauges are animated. But for now, let's just show this as a full screen image on the display, and for that I need to first export that by going into the file, export as PNG file. And this preview might be a little bit misleading, but if I check the artboards and click the save button, it should export me a zip file with 2 images, one for the old VFD display and the second one for our current reflective LCD display. So let's show this image on our display, and for that we need to first convert that image into the C-style array. And to do that I will use the image to CPP website and select our image, so select that image, and there should be the preview down there. And the only thing that we need to change is to click this swap bits in byte checkbox and then click the generate code and copy the output. Then I will jump back into the Arduino IDE, and here is the old image which I can just delete, and instead I will paste the content from the clipboard, and there is this helper array which we don't need, but what we do need is the name of the image, which is up here. So if I scroll up, there should be the image name, which is this one, because I need to use that image name inside our drawing function. So in the main loop, we want to draw the image with this name instead, and the resolution will be 250 by 122 pixels. For now, let's not draw any overlay boxes. And I guess that we are still drawing the full screen background image inside the setup function, and we don't need to do that. I can just delete this part and only keep the begin and set contrast function, although I'm not quite sure if this is doing anything for this particular display. And then make sure that the Arduino UNO is still being selected and try to upload it to the Arduino UNO. And after a few seconds, we should see the new image on our reflective LCD display, and I think it looks great. Which means that the only thing left to do is to try to animate those gauges in a very similar way as I was animating those gauges on the VFD display, so filling and unfilling those gauges. And it should be very simple. We will again draw rectangles in a certain size over the background image, but for that we need to first have the background image with those gauges being fully filled, which means that I need to jump back into Photo P. And in here, I will simply hide those two layers that are covering the gauges and export it again by going to File, Export as the PNG file, and again click the Save button. And again, that will create two files because we have two artboards, and I need to go to the Image to CPP website and select our image again. And again, make sure that this checkbox is being checked and then generate code and copy the output. And then jump back into the Arduino IDE and locate the image, which is this one. So I will again delete this image and paste a new one, but I don't need this helper array. I just need to double check that this name is still the same. So this is the name of the image, here it is. And if I scroll down into our main loop, it seems like that it's still matching, so that's fine. And the next step would be animating those gauges by drawing those two rectangles. Actually, we do have this code in here already. So this is the first box and the second box. We just need to update the positions a little bit. For that, I will again jump back into Photo P. And in here, I will to create a new layer and select the selection tool and select the area of the entire gauge of the inner part of the gauge. So zoom in as much as I can and then select the selection, which might be about this size. And then I will fill it with some different color. So for example, set the color to be, I don't know, maybe blue one, like so. And then go to Edit, Fill with the foreground color. And I might even lower the transparency, the opacity, like so, and then duplicate it one more time. And to get those positions, it's quite simple. We just select the layer and then click this distances checkbox. And that will show us the size as well as the distances to the edge of the artboard. So let me try to make this window slightly smaller. So I can see both the Photo P file and the Arduino IDE. And you can see that we are animating those two gauges to be up to 120 pixels wide. But in our case, we can go all the way to 196. So let me just change it to go all the way to 196 pixels for the maximum width of both gauges. And then we draw those rectangles down there. So one is covering the fuel gauge and the other one is covering the temperature gauge. We need to, of course, change those values accordingly. So the X position will be the left position, which is 45 plus the fuel value. The Y position will be 16 for the first gauge. The width of the gauge will be 196 minus the fuel value, and the height of the covering rectangle for the first gauge is 20 pixels. For the second gauge, I will select the second layer so you can see those values. The X value is again 45 plus the temperature value. The Y is different, it will be 78. The width is 196 minus the temperature value, and the height is again 20 pixels. And I think that's all that we need, so let's try to upload it to the Arduino one more time. And now we have both gauges slowly animated. If we want to play those animations slightly faster, or at least appear slightly faster, we can probably change the increment step. And we do that by going back into the Arduino IDE and change this increment value from 1 to 3, for example, and minus 3. And then down here we have to also update those values, so minus 3 and plus 3, and try to upload it one more time. And now we at least see a little bit of movement. Now one thing that I haven't mentioned is that this display should probably work with 3.3 volts and not 5 volts. And while it works now with the Arduino UNO, which is 5 volts, it will most likely lower the lifespan of the display. Thankfully I have a solution for that doesn't require using a different microcontroller. Because I have those two Arduino UNO boards, one is from elecrow and the other one is from the Seed Studio. And they both have this very useful switch which you can use to switch between the 5 volt logic and the 3.3 volt logic. So let me switch the board to the 3.3 volt logic version and then upload the sketch one more time to this Arduino UNO board. And just so I don't have to reconnect those wires, I have prepared this UNO shield. This is the Arduino UNO breadboard shield, one of my favorite products for the Arduino UNO. I will just snap it on the Arduino UNO and then connect it to the display. And then when I reset the board, I should see the very same graphics being animated on this reflective LCD display, but now it's working on the 3.3 volts, just like it should be. And that's it for today. Again, this is quite interesting display, and the fact that you can use it with the UADG2 library makes it quite convenient. With the number of pixels that you have to update on this display, it would probably make more sense to go with some faster microcontroller like the ESP32. I might try that in the future video. Anyway, that's it for today. If you have any questions or comments, please put those down in the comment section. As usual, all the source files are on GitHub, the link is in the description. Thank you very much for watching, and I hope to see you soon. Thanks and bye.